Operators are what make RxJS so powerful. They allow us to create new observable streams by applying some kind of logic to a previous stream or streams, or we can create an entirely new stream. So if we're coding reactively, then it is generally streams all the way down. We start with a stream at the source, and through the power of operators, combine and modify that stream as necessary until our data within that stream reaches its destination, having been molded and manipulated into whatever form we need. So we don't touch the values themselves inside of the stream, we define computations that apply to any values that pass through that stream. So if you want to code reactively with RxJS, then you're going to need to know how to utilize operators. The alternative is subscribing to your streams early and imperatively pulling out and modifying the values outside of the stream, which is not, at least in the sense of reified reactive programming, coding reactively. So I'll have some links in the description to the difference between transparent and reified reactive programming. But the general idea is if we want to code reactively, then we want to keep our values in the stream until we actually want to use or display them. So RxJS currently has over 100 default operators, and I've probably used less than half of these operators ever. From time to time, I'll use more niche RxJS operators, like in a recent video where I used expand to recursively fetch data. But for the most part, I just use the same 10 or so operators again and again and again. So let's talk about what they are and look at an example of how each one works, first theoretically, and then an actual example with some real code I've worked on. So first up, the map and filter operators. These are probably the most basic operators and they are used a lot. So I have an example of the marble diagram for map here and filter as well. And if you're not familiar with marble diagrams, the basic idea here is that each of these arrows is a stream. This one at the top here is our sort of initial stream, and these circles are data emissions from that stream. So this stream has emitted 3 and 2 and 1. And this bottom stream down here is the stream we get after applying the operator to it. So we're using the map operator here to take the emissions from this stream and apply this transformation on it. So in this case, all we're doing is taking the value from the stream and then we're multiplying that by 10. And so you can see the result of that here. This second stream just has all its values times by 10. And the filter operator is very similar, except we are applying a filter rather than a mapping function. So in this case, we are filtering out any values that don't match this condition, this predicate. So we have x greater than 10. So this second stream is only going to contain data emissions from the first stream that are greater than 10. So you can see we don't have this 1 or the 5 or the 2, but the other values are able to pass through that filter. So the key thing to understand about the map and filter operators is that they operate on stream emissions, not the value of the stream emission. So for example, let's pretend this emission here, this 3, was actually an array of numbers, say an array of numbers 1 through 10. And we wanted to multiply each of the elements in that array by 10. Now this map operator won't work because this is going to take the entire array as a value and try to multiply it by 10. So let's just take a quick look at what would happen here in the console. If I create an array and try to multiply it by 10, I'll just log that out. You can see that the result we get is not a number. So what we would need to do instead is map the stream emission with the map operator to modify the value in some way. And inside of that mapping function, we would then need to map the array itself using the array's standard map method. So this would actually look a little bit more like this. I'm actually going to update this here so you can see. Keep in mind, this isn't actually changing the marble diagram here. I'm just literally just dumping in the new mapping function. But the idea here is that we are using the map operator for the RxJS stream first. So that's allowing us to transform the stream emission in some way. And remember, we're pretending this is an array of values now. And then this is the function we're using to modify that emission. So in this case, we're taking the value from the stream emission, which would be that array, and then we're using a standard map method from the array to transform the values of that array. So these two maps are different. This first map is an RxJS operator operating on stream emissions. This second map is just a standard map operation for an array. And this same idea applies to filter as well. So it's just a bit confusing, I think, because they have the exact same name, but that is an important concept to keep in mind. Okay, so now let's take a quick look at an example from one of my apps to see this in practice, how we might actually use a filter and a map. So in this case, I just have a getChecklistById method. The idea is I want to be able to pass in an ID and get a stream of the checklist that matches that ID. So I return my stream that contains all of the checklists, and then I pipe on two operators. I pipe on the filter operator because I don't want to emit anything if the checklists haven't loaded yet. So if there are no checklists available, I won't get any stream emissions. And then I use a map operator to actually handle finding the specific checklist that I'm interested in. So this map operator is going to get all of the checklists, and I take that array of values and I use the find method to get the specific checklist that matches the ID passed in. So we start with a stream of all of the checklists and we finish with a stream of just the one checklist I'm interested in. Okay, the next operator I always use is the tap operator. So tap doesn't actually do anything to the stream. You could add or remove a tap and it will have no impact on the end result of the stream. What it allows you to do is observe values at certain points within the stream, which is useful either for just quick and dirty debugging, you just want to see what this value is at some point in time, or creating a side effect. So we can observe a value from the stream and go trigger some other code without affecting the stream itself. So the debugging use case is obvious enough. Something weird is happening, so you could just chuck a tap in there and console log out the value to see if it's what you expect. As for side effects though, here are some examples of when I might do that. So in this example, I have a route guard that is protecting the login page. And with the canActivate method here, I'm using a stream from my auth service to determine whether the user should be able to access this page or not. But as well as preventing them from accessing the page, if they're not allowed to access it, I also want to navigate them somewhere else. So what I do is I use tap on this stream to check the value. And if the value is something that means they can't access the page, I am triggering this side effect and forcing them to navigate away to a different route. I have another tap creating a side effect in this service here. So I have this getPhotos method, which returns a stream of photos. And basically I've just set up this side effect here so that every time this stream emits a new value, it's going to set those values in local storage. So I use the tap here, take in the value of the photos, whatever the current latest photos are, and then pass them to storage. And one final way that I also commonly use tap to create a side effect is when I'm using NGRX component store. This is actually sort of how it's designed to be used. But the basic idea is we might have some effect here. For example, I've got this effect to load in clients. And then in the component store, I have my client state defined, which includes an array of clients. So I load those clients in from my getClient stream, and then I use tap to create this side effect, which will handle adding the value of clients to the state. So side effects like this are useful, but inappropriate use of side effects can lead to code that is harder to understand and optimize. So if you can achieve something cleanly without a side effect using tap, then it is probably going to be a good idea to do that instead. But sometimes it is just genuinely useful to use tap to create side effects. Okay, so now we're getting into the territory of combining streams together. So we're going to look at switchMap and concatMap. And these are both similar, but we are going to focus on switchMap first. So switchMap allows us to switch from one stream to another stream. For example, I might have this stream emitting the values A, B, C, but I want to switch to this second stream emitting 1, 2, 3 instead. Now that might seem a bit pointless. Why even bother with this letter stream? We could have just started with the number stream. But this is where the map aspect of it comes into play. So I don't just want to switch to the new stream. I want to take the values from the first stream and use them in the second stream. So looking at this example marble diagram is a bit abstract, I think. So let's jump straight into a real example that I do all the time. So in this code snippet, I am grabbing a parameter from the route, an ID, and using that to get some specific record. So I start with this stream of params from the route because that has the ID data that I need, and then I use switchMap to switch to a new stream. So what I really want is a stream of these feedback documents, but switchMap allows me to first get the ID value from the param map, from this stream from the route, and pass it into this second stream, which I can then use to filter out the specific document I need using its ID. So if I had have just started directly with this feedback stream, for example, I wouldn't have access to this params.getID method, so I wouldn't have a way to filter out the specific feedback document I want. But since I do need this value, I start with the stream that has that value, and then I switch map into my second stream, passing in those values that I need from the first stream. So I do this all the time, get some value I need from one stream, then switch map to another stream that makes use of that value. And the thought process will often go something like this. I'll have this stream of feedback, for example, and then I'll be like, okay, well, I need the feedback documents, but I need to filter it based on some value. So I'm like, okay, well, now I'm going to need the ID from the route parameter, for example. So then I'm like, okay, well, I'm going to have to start with the stream of that ID then, and then switch map into the stream I actually want. So I often just think about it in terms of all the ingredients I need to get the final result I want. In this case, I need the feedback documents and I need the ID. And then in some way, I'm going to need to mix those streams together to get the end result. And often that means using a switch map, but as we'll see in a little bit, we can also use some other operators. And when considering switchMap in comparison to concatMap, it's important to consider its cancelling behavior. So imagine this second stream that we are switching to might take some time to complete. Maybe it's an HTTP request that will take a few seconds. So it's not going to happen in this case, but what should happen if our first stream emits another value in this time? So this hasn't completed yet, and we're already getting another stream emission coming through that's getting switch mapped, and we want to make another request. So in the case of switch map, if a new value is emitted from the first stream, this inner subscription will be cancelled and a new subscription will be created using the new value. So if this hasn't finished doing its work yet and a new value comes in, switch map is basically saying, never mind, cancel that, here's a new value, do this instead. So imagine something like a search scenario. If the user enters a new search term before the previous search term has finished hitting the API, then we just want to dump the old request and search for the new one instead. And so this is what switchMap will do. But concatMap, on the other hand, will wait for each inner subscription to finish before moving on to the next stream emission. And so this is essentially creating an orderly queue. So let's take a look at some examples of that. So in this case, I have a stream of all of the photos in the application, and I want to display those one by one with a delay of 500 milliseconds. So I use concatMap in this case because each time I get a stream emission of a photo, I want to make sure this completes before moving on to the next one. So I'll get one photo coming through, wait 500 milliseconds, this is completed now. Now it can move on to the next value that was passed in from the first stream. Again, wait 500 milliseconds, move on to the next one. So each stream emission gets addressed in the order that it arrived. Whereas with a switch map, this wouldn't happen. Whilst we're trying to wait 500 milliseconds, we would get a new value emitted on the stream, and it would just cancel this and be like, oh, never mind, display this one instead. And the end result will be basically just going straight to the last value that's emitted immediately, rather than waiting 500 milliseconds for each one. And I've got another example here as well. I actually have a full video on this stream because it's rather complex, so I'll link to that if you want to check it out. But I am also making use of concatMap here. And the reason I'm doing this is because I first have this stream of pagination value. So I want to know what page I'm on, going from page 1 to 2 to 3. And in this case, I'm displaying an infinite list of GIFs. So if I get page 1, then page 2, then page 3, I want to make sure I load all of those in order because I want one long list of GIFs. If I were to say go to page 2, but before page 2 had finished fetching, I then trigger page 3, if I had used switchMap, for example, then it would just ignore page 2 because it never completed, and it would just be like, oh well, we'll just forget about that and move on to page 3. With concatMap, it will wait for page 2 to finish and then move on to page 3. Now, another common operator that is similar to these two is mergeMap, but interestingly, I hardly ever find myself using a mergeMap, which actually kind of surprises me. So a mergeMap is like a concatMap. It will complete all inner observables, but whilst concatMap will address one at a time in order, mergeMap is more like a free-for-all where everything is just subscribed all at once regardless of order. So if the order doesn't matter and you just want to get everything done as quickly as possible, you can use a mergeMap. Okay, next up is combineLatest, which I typically use most of the time creating view models for my templates. So this is a creation operator, so it isn't piped like many of the other operators. It is used to create a new stream from scratch. So the general idea is that it will take the last emission from each of its input streams, so the 5 and the D in this case, and it's going to emit them all together. So importantly, combineLatest will wait until all input streams have emitted at least one value. So if this second stream here hadn't emitted anything yet, then our combineLatest stream also wouldn't emit anything. And again, this is going to be easier to understand if we just look at a real example. So you can see here I am creating a view model stream, which is a stream of all of the data I need for my template. So specifically, I need the checklist that I am looking at, the items for that checklist, whether the modal is open, and the ID of the checklist being edited if there is one being edited. So I'm passing in 4 separate streams to this combineLatest operator, and then it's going to emit the latest value from each of those 4 streams. So I get all of those emitted at once, and I can just use this destructuring here to grab each of those values. And then I'm just mapping those values into a format that is just more convenient to use in my template. So if we do have a look at the template here, we can see I am making use of this VM stream. So in the modal, for example, I'm using the async pipe to describe to the view model stream. We're using that as VM, and then I'm using the various values here. So I'm checking here for the checklist ID being edited. I'm using the for modal is open here. I'm using the checklist ID over here. So this just creates one nice simple stream that I can use to access all of the values I need for my template. Okay, so now let's talk about startWith, debounceTime, and distinctUntilChanged. So these ones I find myself mostly using when working with forms, although they certainly do have other use cases. So let's have a quick look at these marble diagrams. So startWith basically is going to allow us to start the stream with a specific value. So we have a stream of 2 and 3 here. We're saying we want to start it with 1. And so now 1 is the first emission on that stream. If we use debounceTime with a value of 10 milliseconds, it's going to make sure that there is at least 10 milliseconds between each emission. So if we're sort of spamming the stream as we are here, there's 2, 3, 4, 5 all very quickly together. It's going to wait until there's a gap of at least 10 milliseconds before emitting something. And so that's why we only get the 5, because all of these would have been within 10 milliseconds. But if I say move this out a bit, now there's a gap of 10 milliseconds, so the 4 gets in there as well. Again, if we spread these out, we can see more and more values popping in. So this is good in situations where maybe you have something being hammered very quickly, maybe a user's typing, for example, and we don't want to be spamming requests to an API. And then we have distinctUntilChanged, which is basically just going to emit the value only if it has changed. So you can see here we have 2 being emitted twice, but we only get it emitted once. But if I were to switch these 2 values, now we're going to get all of them because the value is changing every time. Okay, so now let's see this in action. So this is connected to an input field for searching for a particular subreddit. So you can see I'm using the value changes stream here. So inputs like this make a lot of sense with operators like debounceTime and distinctUntilChanged. Since a user is typing, I'm going to get an emission for every single keystroke. But you probably don't want to hit the API for every keystroke. So we can add a bit of a buffer, 300 milliseconds in this case. So it'll wait for 300 milliseconds of idle time before hitting the API. So you can imagine the user might be searching for the GIFs subreddit, for example, and they're going to type GIFS. And so I really only want to launch that request when they're done typing. I don't want to send a request to search for the subreddit G because I'm just going to get an error, and then GI and the GIF. All of these are just pointless requests to the API. And distinctUntilChanged is also useful in this circumstance because, as we just talked about, it's only going to emit if the value has changed. So if I've already searched for the GIFs subreddit and the value is GIFs again, I don't need to redo that. And finally, the startWith operator is usually convenient when working with the value changes stream from reactive forms, because value changes will only emit when the user actually types something in the field. So if we want some default value before the user has actually typed anything, then startWith is a good way to achieve this. Okay, now for the last one, let's end with something interesting. So catchError, it's not the most exciting operator, but it is important to handle your errors, especially with observable streams, because your entire stream will be destroyed if you don't catch and handle an error. So this is an example of handling that in a boring way. We just pipe on the catchError operator, and we are just silently catching any errors and returning an empty observable stream to prevent our stream from breaking. So the general idea with catchError here is an error has occurred, the stream has broken, and we're returning a replacement stream. So this stream could be whatever you like. It could be any kind of new valid stream, but an empty stream will basically just do nothing, but make sure that our whole process here still works on the next stream emission. But you can also do some pretty creative stuff. So in this case, I have a stream of data from Firestore that is going to error when the user logs out because they no longer have the appropriate permissions to access that data. So naturally, this is going to happen at some point and it needs to be handled. And remember what I said about observable streams and errors. If this errors, then it is bye-bye stream. Even when the user logs back in and they have the correct permissions again, the stream still won't work anymore. However, you can see I'm doing something a little bit different here. I'm not just catching the error and returning an empty observable like the other time, because I need something specific to happen here. So when the user logs out, I need to clear any data stored locally, and I want to make sure the stream can be restarted when the user logs back in again. So I get a bit creative with catchError here. So when the stream errors, I catch the error and I return a new stream using concat. This is a creation operator that we haven't talked about yet, but basically this is going to allow me to combine these two streams together. So the first stream is just going to emit a single null value. And then this is a signal I use in my data store to clear the data. So I'm detecting an emission of a null value, and if I see that, I'm going to wipe out all of the local data, and then I just rethrow the error. So this whole section here is specifically just because I want some special handling somewhere else for when an error occurs, but you could also sort of just pretend this bit doesn't exist. The main thing is this retry when. And this is what is responsible for restarting the stream again when the user logs back in. So the stream has errored, it's broken, but we want to fix it, we want to restart it when some condition occurs. So I use the retry when operator to wait for this stream to emit a logged in user. So when a user does log in with a valid user, this stream will try to restart again. And since the user is logged in, it should succeed because they now have the appropriate permissions again to get data from this collection. Okay, so that's about it. Despite RxJS having like a million operators, I generally only ever use these 10 or so operators. Now, obviously I have specific types of applications I generally work on, so it might not line up exactly with other people's experiences, but I suspect that the operators I've mentioned will generally be quite popular across a broad range of situations. And if you do know these operators, you're probably going to do pretty well in most circumstances. RxJS operators can be tricky to wrap your head around for sure, and the prospect of having to learn 20 or 30 or 50 of them might seem impossible, but dedicating some time to learning, say 10, isn't so bad. And with a sense of how some of the operators work, it's much easier to then just look up operators as you need them. In the end, they all work in more or less the same way. They take one or more observable streams as a parameter, do something with the stream values, and return a new stream. Once you kind of get used to this idea of sort of streams within streams and inner observables, inner subscriptions, that kind of thing, that's really probably the hard part of understanding operators. Once you start getting that down, you can probably understand just about any operator just with a little bit of research. Okay, so that's it for this video. And remember, your observable streams won't actually do anything until you subscribe to them. It's not the same with my channel, but if you do feel like subscribing, it would be much appreciated. And I will catch you in the next video.